So in this video, I'm going to create a function that accepts a vector of x values and uses a for loop to calculate the corresponding y values, and it's based on the equation y equals x squared plus 1. Alright, so jumping across to Matlab, what we want to do is start ourselves a new script window. And I'm going to go with, rather than creating this as a function initially, so using the function keyword, giving us outputs and inputs and so on, I'm just going to leave it as a script, which is where we don't do any of that, and just make sure that it's all working. I find it a bit easier to troubleshoot it in that kind of mode. And then once it is working, we can do a conversion over it to it being a function. So what I'm going to pop up on the beginning of this is clear all and close all. This is just to keep my workspace clean, so it means that at the beginning of each run of my script, it's going to clear all of the variables that are in the workspace, and it's going to close any figure windows that we have open. And this just means, yeah, we're starting clean each time we run the code, so previous runs can't infect new runs. Alright, so I'm going to give us this test case for x values. Let's go with like 1, 3, 5, and 7, something like that, just as a test again to see if it's going to work. Alright, so we've been told that we need to specifically use a for loop for this process, which means that we can't do any of like the vectorization or the little like dot operators. Okay, this needs to be completely done within the for loop. So the keyword for Matlab is for, and then what we give Matlab is a vector, usually it's a count variable, that it's going to run through as it goes through the for loop. So often people use the letter I for this purpose. And what it's going to do, as I said, is a count variable, so it's going to count the number of times we go through the loop. So if I've given us this test case where we've got 4 elements of x, what we're going to need to calculate from it is 4 elements of y. I'm going to say that we're going to do this by going through the for loop 4 different times. And on each occasion, we'll get one of these outputs falling out. So how I can tell Matlab that is I want to start at 1 the first time through the loop, and I want to run up until we go through the loop 4 times. And if you want to see what this looks like, you can just chuck it in the command window, and you can see it's just going to be 1, 2, 3, 4, literally counting the number of times. So the other kind of keyword that we need to give Matlab is end, and you saw it kind of highlighted. It will underline which one corresponds to, which for corresponds to which end as well, if you ever get confused and have multiple for loops or multiple if statements, things like that. Yeah, so each for needs an end associated with it. Alright, so now we need to program what we want it to do inside the for loop. And of course that is to calculate the corresponding y value for each of these x's. So the equation that we had was y equals x squared plus 1. Okay, and I'll pop a little semicolon on the end there just to stop it from highlighting. So what it's going to do is we're going to clear all our workspace, we're going to close all our figure windows, and we're going to define this vector x. Next we hit this for loop, and we're going to start with whatever the first value is in this vector. So in our case, our first value is 1, and it's going to come down and define a new variable y, and it's equal to x squared plus 1. So at the moment, it's going to read out whatever the x vector is in its entirety. Okay, and what we're going to find if we run this, it's probably not going to work because it's going to try and square this entire vector, which is like doing the matrix multiplication. And if we run it, it's going to complain. Oh, I'll save it. All right, that's because we're trying to square a matrix, all right, matrix multiplication. And you can see that this matrix here, it really can't be squared, all right? To square a matrix, it needs to have the same number of rows and columns, okay, which we just don't meet, okay? And in fact, this isn't really what we wanted anyway, right? We just wanted to read out whatever the x value was, the first one, and square it, all right? And then add 1 to it, and that would be our corresponding y. So how we do that is we tell Matlab, rather than going and reading out the entire x matrix, go and look at a specific element in it, and I'm going to call it I, the ith element in that matrix. So remember we said the first time we go through this loop, I is equal to 1. So if I is equal to 1, it's going to look up the first element in the x matrix, which is of course a 1. If we then roll through the next time, I would be equal to 2. So what it's going to try and do is look, okay, this I would become a 2, look in the second element of our X matrix. So it should then read out a 3 and draw it into our formula. It's going to keep doing that. So the next time it goes through the loop, I would be equal to the third value, which is 3. It then goes and draws out the third element of X, which should be a 5, squares it, and adds 1 to it. And it keeps going and going and going. So if I run this now, right, what we can do is have a look at what our Y value actually is. And we can see it's not quite what we wanted. It's just giving us the number 50. So what this is going to correspond to is each time we run through the loop, we're going to overwrite this value Y. So really all we're going to save is whatever the last thing that happened. So that would be where I is the last value, which is 4. It would read out the fourth element of our X matrix, which is 7. So 7 squared plus 1 would give us 50, yeah, 49 plus 1. And that's what's getting saved into Y and is being outputted at the end of our code. So again, not quite what we wanted. So what we can do to get around it and save all of the values that we get corresponding to the X's is we can tell Matlab, rather than going and overriding the Y variable, we can tell it where to write it in this Y variable and make it a vector rather than a scalar or just a number. Right, so now what it's going to do is the first time we go through the loop, I is equal to 1. And it's going to go and look at this Y variable that we're defining, and it's going to write to the ith, or the first element in it. So whatever gets calculated out, again, if I is equal to 1, it's drawing in the first X value here. That's going to get written to this first Y1. So then the next time we go through the loop, I would be equal to 2. So then it would go and look at this Y variable, and it would write it to the second element in it. Right, again, it's going to then be drawing in the second X value and then adding 1 to it. So now if I run this code, we can see what we get out at the end. So Y, we can see it's now a vector. It's got 4 elements in it, and each of these should be corresponding to the X value in the same position. Now, if you want a way of visualizing this a little bit better in terms of what's happening, you can use something that's called breakpoints. So what this involves is like clicking on one of these executable lines, and it's going to pause the function at that point. So if I click here, all right, it's going to pause when it reaches that point in the run. So run it. So it's cleared, it's closed, it's defined this X variable, and now it's entered our for loop, and it said I is equal to 1 on the first run. And it should have calculated for me what Y was in the first element, and you can see it's doing it here. It should have read in what the correct X value was, squared it, and added 1, and then it stopped. So you saw you can hover over the top of a variable and it tells you what it thinks it is at this point in time. So you can see it's thinking at the moment that I is equal to 1. If you hover over Y, at the moment it's only defined the first value in that vector because it's only gone through the loop once. So Y is equal to 2. And this one, it's going to be reading, you can see here, the first value from our X matrix. So it should be reading out the number 1. All right, so that's going through the loop the first time. If you want it to continue, you can see there's a continue button up here. And you click it and it will execute whatever's next until it hits this breakpoint again. So now what we should see if we highlight, I is equal to 2, all right, it's going through the loop again, and it's going to have to find the second thing in our Y matrix. If we go once more, it should iterate again, so I is equal to 3, and it will have found the third thing in our matrix, or vector. And if I click once more, it should pretty much reach the end, I think now. I is equal to 4, and it's defined what the last Y value is. So down here you can see it's got a little K here when it's in this kind of debugging mode where it has the breakpoints, and it tells you down here as well that at the moment it's paused in the debugger. So it's stuck at the end. If we continue now, it should go to the end of the code, which is nothing after it. All right, it disappears here, and it will take away the little K thing as well to tell you that you're not in that mode anymore. So that's a really good way of just double checking that your code is like kind of doing what you think it is, while you're there. So once you're done with that, you can click and it will take off the breakpoint and it won't do that anymore. All right, so a couple of last things to kind of talk about here. One of them is that at the moment I've defined this random test matrix, and based on that test matrix, we decided that we should run this 4 times. But what would happen if I had an extra point in here? Alright, I would need to run it through an extra time, which would mean I'd need to update this I vector. So to get around that, one thing that you can do is, rather than having this manual kind of process, is you can use a function. So there's a function called length, right? And this reads out the length of a vector or a matrix. So in this case, we want the length of x to correspond to the maximum number of times we run through the loop. And if you ever want to check what it's going to do, if you pop it down here, it's because I didn't redefine what x was. Let me run. Alright, so now I've redefined x. Alright, it has that extra element in it. So now when I try and query the length of it, it tells me it's got 5 elements in it. Alright, so now what's going to happen is when we run through, it's going to still always start it the first time through the loop, but the maximum number of times is going to be drawn in from whatever the length of this vector is. And that's pretty common when you're defining for loops. Usually the number of times that you want to go through the loop is going to be dependent on some other parameter. And we can see, well, it's up here even, the y values that we've got 5 of them falling out, and they should correspond to each of these x's. Alright, so now what I'm going to do is flip this over, now that I think it's working, into being a function. So getting rid of our clear and close, and I'm going to use the function keyword. Remember, we give it outputs in the square brackets equals the name of the function, so let's call it, I don't know, test1, and then we give it the round brackets with the inputs. So in here, the only input we're going to have is that vector x that we need to calculate the corresponding y values to. So I'll delete it in here. And then our output, the only thing we want out of our code is the y. So you can see that this is highlighting, right? It's telling me that it's not happy because my code is actually called Untitled 8, but it needs to be called the same thing as what I've got in here for it to work. So I'll just save it as, and we'll call it test1 to keep it happy. And now what we should be able to do is, if we save it, and we can copy this to test it, let's give it an x vector to test. I don't know, 1, 2, 3, 4, 5. So when we run it, I gave it 45, sorry. So when we run it, we can see that it's calculating the y values that we get out. If we had to change it, so let's make it 4, 5, all right, we can see that it now gives us 5 values, which is what we would expect. So it seems to be working correctly. The only other thing I want to mention is that if you highlight over this, it's going to tell you that the variable y appears to change size on every loop iteration, and unfortunately this costs Matlab a little bit in terms of speed of executing your code. Now for our purposes right here, it's really not going to make much of a difference, but what you can do to kind of get rid of this kind of warning that it gives you, or tip I guess it gives you, is it wants you to pre-allocate what y is. Okay, so if you tell it up at the beginning that y is a vector, one way of doing that is to just pre-allocate it with zeros, so I'll do that, and you give it the size of that vector that you're going to write to. So we know that our vector is always going to have one row, okay, that we see here, and the number of columns that it has depends on whatever the length of x is, right? It's got the same number, so we can use that function call again to be the length of x. And I'll suppress it. If you want to test what this looks like, pop it down here, and you can see that it's defining y as a vector that's got 5 zeros in a row. Okay, so that's just a way of getting around that little warning that it gives you. And if we perform our little test thing once more, this one here, you can see that it still operates the same, but it will be marginally quicker in executing it in Matlab. So that's pretty much all there is in terms of this video.